We're going to begin naming these right triangle ratios, and the first one we're going to start with is the tan ratio. And the tan ratio is specifically when we compare the sides of the opposite to the adjacent. Okay, and when we compare this, the opposite is in the numerator, adjacent is in the denominator. So when we talk about angle A, we're talking about the opposite side of angle A, so this one here, compared to the adjacent side length of angle A, which is that length horizontally. So it's vertical to horizontal, and essentially that ratio is going to be the same as slope, or rise over run. So this is the first ratio, that specific named ratio that we're going to deal with, and it's the tan ratio. So we can write these ratios as either fractions, where we can see clearly the opposite and adjacent side, or we can do this as a one number ratio or a decimal ratio compared to 1. And when we do the one decimal ratio, we just have to be clear that although you see one number, the other implied number is always going to be 1. So looking at the tan ratio for angle A, okay, so when I look at angle A, the opposite side is going to be 3. So tan ratio is going to be 3 over 5. Sorry, not 3 over 5, but 3 over 4. 4 is adjacent side to angle A. And so there's our ratio. We can write this as a one number ratio of 0.750 to 1. And although I'm not going to write the 1 is always implied. So when we look at the angle B, the tan ratio for angle B, again, we go to the opposite, which is in this case going to be the vertical side, over the adjacent, which is now going to be the horizontal side. So we get 4 over 3, and it happens to be the reciprocal ratio of angle A. And so 4 over 3 works out to be 1.33 repeating. So I'm going to write that as 1.33. We generally use 3 decimals for the ratios. And although it's a one number ratio, the other number that's implied is 1. So looking at example 2, angle A, we have to first of all identify the opposite side. Well, the opposite side is not given. So if we need an opposite side, if we have two sides of a right triangle, we can always work out the third side using Pythagoras. So we can call that side x, and we can say that x squared is equal to the long side squared minus the short side squared, or 225 minus 100, and x squared is going to be equal to 125. X works out to be the square root of 125. So as a whole number ratio, we're going to do, now we can compare those sides. So x is equal to square root of 125. So then angle A, the ratio will be the opposite, which is square root 125, over the adjacent side, which is 10. And as a decimal, we can just work this out on our calculator. As a decimal value, this works out to be square root 125 divided by 10, and that's going to be 1.118. If we take a look at angle B, from the angle B perspective, the opposite side now is a vertical side. So 10 over, the adjacent side now is square root 125. And so if we take the reciprocal, we end up with 0.8944. So I'm going to round that to 0.894. And again, as a one number ratio, that's a number being compared to 1. So it's going to be, what we're saying is that the opposite side is about 89% the length of the adjacent side. For example 3, again, we'll take a look at the tan ratio for angle A. So first of all, we identify the angle A. and then we identify the opposite and adjacent side. So the opposite side is root 32, the adjacent side is 7. As a decimal value, and again, we really actually want to keep these exact values, but sometimes we do need to use a decimal, so we're going to convert this to a decimal. Root 32 over 7 works out to be 0.808, and again, that's 0.808 to 1, and the 1 is always implied. For angle B, we take a different perspective. The opposite side is 7. The adjacent side in this case is root 32, and as a decimal value, that works out to be 1.237. So this is 1.237 to 1. So again, it's important to note that first of all, we need to identify the angle that we're talking about, and then do it in the correct order, opposite and adjacent. So you have to go to the opposite side. So for example, angle B, we first start with the opposite side, and then we go to the adjacent side, and it's the opposite over adjacent. And if we take a look at from the slope perspective, it is really just slope. It is rise over run.